So we're going to start with difference equations, which are discrete models, so no derivatives. We saw the example of the rabbits in the introductory video. I've sent you this handout, and your assignment is to read through it. There's preliminary definitions and examples, and a couple of which we've seen. Here's one with the bank interest, which is the same as the rabbit example, actually. A theoretical result which gives us the solution, analytical solution. Now, Excel is great for doing recursions. These spreadsheets are tailor-made for it. So what I want to do is go through some of these examples with you. And by the way, so this is your first homework assignment, and it will be due the first week that we meet. That is the week of January 23rd, which is a Wednesday. So if you have lingering questions on this, we can get to them on Wednesday the 23rd, but I expect that you will have done most of these or made very good headway on them. And I'm going to get you started with that right now. Let's look at the first problem. So a patient is given an initial dose of some drug and then given another dose every 4 hours. By the end of each 4-hour period, 25% of the drug in the bloodstream has been eliminated. So what we want to do is come up with a mathematical model with a difference equation, and then look at the solution in Excel, and I'll show you how to do that. And then there's a couple of other questions that you'll have to answer. So let's try to model that situation. So if Q sub n is the amount at the nth stage, in other words, after the nth administering of the drug, then what happens when you administer for the n plus 1th time? Well, what you had at the nth stage, 25% has been eliminated. So you've only got 75% of that left. But then you're going to add 2 centimeters. So there's your model, right? There's your difference equation. And note that our model is a first-order linear difference equation from the handout here, because it has this form of equation 4 in the handout. A is a constant and B is a constant. Notice we have a formula for analytical solution, which you'll be asked to apply. But for now, I want to generate the solution recursively in Excel, and I'm going to give you this Excel spreadsheet just as a template. And there's not really much done here. All I did was enter in the value of n and the column headers here. So I'd like this to be the value of Q sub n. Okay, so after the first dose, I have 2 cc's, right? Well, what happens at n plus 1? Here's where our formula is going to go into action here. So at the n plus first stage, which if n is 1, n plus 1 is 2, it's going to be 0.75 Q sub n plus 2. So if you've never entered formulas in Excel, here's how you do it. You type equals, and Excel will know that it's a formula. And what I want to do is I want to multiply Q sub n, so I just click on that. So this is cell C and row 5, so it's called C5. And then I want to multiply that by 0.75, and then I want to add 2. Okay, so that's Q sub n plus 1. In this case, if n is 1, this is Q2. Well, great. Okay, so now if n is 2, I want this value to be 3.5. So what I'm going to do is I'm going to refer by typing in equals. I want that Q sub 2 to be this value up here. And now what's cool about Excel is that I can copy these formulas all in one shot, and it knows what I want to be referring to. So if listen, the way that you do that, oops, let's get out of there. Yeah, that's okay, but I didn't want that. What you want to do is highlight the cell or select the cell. Now that's different than if you double click on the cell, then you're inside the cell and you're in the formula, and you can hit the escape button to get out of that. But you want to select the cell and then mouse over the corner and then click and drag all the way down. Well, 28 is good enough. Now these are all going to be zeros because there's nothing in these values here, but if you click on one, you can see that it's really referring to the cell that you want it to refer to. What I need to do is do the same thing with that formula there. And there you go. So you can see what's happening here. Or can you? Well, it certainly looks like over time the values are starting to approach, they're approaching a limit, right? You might guess that the limit is 8, right? So this is Q28, this is going to be Q29, so after the 29th dose. So if you continued this a bit further, you'd probably get it as close to 8. That's my guess, and in fact it is 8. And you can confirm that analytically using the formula. You use this formula here. Now A is not 1. In our case, A is 0.75. And okay, so it's a simple formula, easy enough to compute that. This solution is a sequence, right? And we're looking at the limit as n goes to infinity. It looks like that limit is 8. So simple. Similar, okay, so let's look at a couple other problems here. This one is very similar to the rabbit example. And the key here is that you have compounding at the end of each year. So since it's not continuously compounded, it's not going to be a differential equation. This is going to be a difference equation. So this is something you would have seen in pre-calculus. Okay. There's a template for that. So in this spreadsheet, I've got a different sheet down here on the bottom, see, for each of the problems. And there's one that I didn't include here, and what you're going to need to do is hit plus and add another sheet like that, right? So let's see. Now I just gave you a little push here with some of the information and parameters. Now there's one thing when entering formulas, when you want to refer to a value in a cell, you sometimes need to lock the value of that cell, and I'll show you how to do that. So if this is my my year, and here's a quick way to do years, multiple years. If I highlight or select both of those columns and then drag, Excel knows that I want to do in increments. And you got to grab both 1 and 2 to get it to do that. Okay, so sometimes when you have parameters here, it's nice to put them in separate cells so that you can refer to them. That way you can change them, and it changes all subsequent computations. Now what I'm going to do, just convenience, is insert a row here so I can have a 0th value, and I want this Q sub 0 to be my initial amount. All right. So let's formulate our model. So at our n plus first year, we have what we had before plus 5%, right? Plus we're going to add $5,000. So our model looks like this would be 1.05 Q sub n plus $5,000. Okay, so let's implement that in Excel. So Q0 is the initial amount, right? And now what's Q sub n plus 1? Well, this is going to be the interest actually it's 1 plus the interest. You're going to need to use parentheses here, times that plus this. Okay, so there's only one difference compared to the last example, is that now that we have these parameters here that we want to refer to when we copy these formulas, I want each formula in each cell to refer to the same parameter value, the same contribution and the same interest. So what I need to do is lock these the rows. If I didn't do that, here's what would happen. First, I want this to equal this, right? If I didn't lock the rows, here's what would happen. Okay, so this formula refers to, see, it refers to these guys, and I want it to refer to these guys up here, right? So what I really want to do, the way that you lock the rows is as follows. You put a $, will lock the column B, right? And the $sign before the row number will lock the row. In this case, we really don't even need to lock the column. We could get away with this. We only need to lock the row. As we drag this formula down, we want the row to be locked. I'll often lock the column as well, or vice versa. But if we wanted to drag the formula to the right across columns, and we wanted this value to stay the same, we'd have to lock the column. So let's just lock the row for now. And let's see, the same thing with the yearly contribution. You want to lock that row. Okay, now if I drag this formula down, it should be okay. All right. And you're gonna, if you want to complete this, you're going to do this, and you're going to do this. All right. So this, if you click on these formulas, it does let you know that you're referring to the right cells. Okay. Right. So you can see that at the end of year 4, we've got this much money, and so on and so forth. So this should get you pretty much started on the way to doing these problems and basic Excel functionality if you didn't already know how to do that. This example is Newton's method, which is also a recursion, you might remember, and you can see this one is actually done for you. Actually, I think in the handout it's the square root of 2. So, but the problems ask you to play around with this a little bit, and for different initial guesses. Okay, here's the Newton's method formula. And then there's also a problem with stocking a lake with fish, which is similar to the one that we just looked at. And then here is a second order problem. So here x sub n depends on xn plus 2 depends on the previous 2. So that's a second order. See if you have a go at this one and see what you come up with. So there you go. There are your homeworks. I'll be sending you, or I've sent you the spreadsheet. And good luck, and I'll see you on the 23rd.